Welcome again to Math 800 Pre-Algebra. Today we are doing section 1.6, Multiplying Integers. Our objectives. 1. Use a raised dot or parentheses to express multiplication. 2. Multiply integers. 3. Identify properties of multiplication. And 4. Estimate answers to application problems involving multiplication. Numbers being multiplied are called factors, and the result is called the product. This word factors is going to be very important, and we are going to use it a great deal when we get more into algebra. Rewrite the multiplication in 3 different ways. Many of you are used to seeing multiplication written with an x. However, as we get into algebra, we will use x as a variable, and it can be confusing if sometimes you use x as multiplication and sometimes you use x as a variable. So we are going to flip over to 2 different notations, the raised dot, 10 times 7, or parentheses, either 1 set of parentheses or 2 set of parentheses. I should note that in some cultures, the raised dot is what they use for a decimal point. So in some countries, this would mean 10.7. If that is true for you, I would recommend using the parentheses to avoid confusion. I, however, will use both, and sometimes I'll use them in combination. Again, the factors would be 10 and 7 because that is what is being multiplied together, and the result is 70, or the product is 70. A quick note about parentheses. Parentheses are used to show several different things in algebra. Earlier, we used parentheses to tell you what to add first. When we get more into order of operations, we'll talk about that again then, that parentheses mean do this first. However, now we're using parentheses to indicate multiplication, like 3 times 5 or 3 times 5. It can get confusing that parentheses are used for different things. You just have to be careful and think, am I doing an order of operations where I have to do one thing first, or is this simply telling me to do a multiplication? So let's talk now about multiplying 2 integers. If the 2 factors, remember those are the things being multiplied together, have different signs, the product is negative. Different signs meaning one is positive and one is negative. So for example, a negative 2 times a 6 would be a negative 12, or a positive 4 times a negative 5 is a negative 20. It does not matter which order they're in. It also does not matter what the sizes are. That's different than when we're adding and subtracting. When we're adding and subtracting, it matters which number is positive and which number is negative. For multiplication, it doesn't matter. If one is negative and the other is positive, then the result will always be negative. If the 2 factors have the same sign, the product is always positive. For example, a positive 7 times a positive 3 is a positive 21, or a negative 3 times a negative 10 is a positive 30. So here, it doesn't matter what the size of the numbers are. It's just that if they're both positive, the answer is positive. If they're both negative, the answer is also positive. Let's look a little bit at why this is. So why is a negative times a positive a negative? First, we'll look at repeated addition. If you have 4 times 3, what you're really doing is taking 4 and adding itself 3 times. That's what multiplication means. 4 3 times. 4 plus 4 plus 4, which is 12. So 3 times 3 would be 3 added 3 times. 2 times 3 would be 2 added 3 times. 1 times 3 is 1 added 3 times, and 0 times 3 is 0 added 3 times. This continues even when we get into the negatives. A negative 1 times 3 would be a negative 1 added to itself 3 times, and a negative 1 plus a negative 1 plus a negative 1 is negative 3. Negative 2 times 3 is negative 2 added to itself 3 times, which gives you a negative 6. Same with negative 3 times 3 and negative 4 times 3. You can also just look at the pattern. 4 times 3 is 12, 3 times 3 is 9, 2 times 3 is 6, 1 times 3 is 3, 0 times 3 is 0. Notice that at each stage we're going down by 3. 12 minus 3 is 9, 9 minus 3 is 6, 6 minus 3 is 3, 3 minus 3 is 0. If this pattern continues, when we get to negative 1 times 3, we should take this result and subtract 3 from it. 0 minus 3 would give us negative 3. And we could continue. Negative 2 times 3 should be this result, negative 3 minus 3, which gives us negative 6. And this continues. Negative 3 times 3 is negative 9, and negative 4 times 3 is negative 12. And again, this pattern of subtracting 3 continues no matter what. So an example, negative 2 times 8. Since you have one negative and one positive, they're different signs, so the answer is negative. So negative 2 times 8 is negative 16. Why is a negative times a negative a positive? Let's look closer at that pattern. So as we saw, a positive times a negative is a negative. And so we have all of these. Here, though, instead of subtracting 3 each time, we're actually adding 3 each time. Negative 12 plus 3 is negative 9. Negative 9 plus 3 is negative 6. Negative 6 plus 3 is negative 3. And negative 3 plus 3 is 0. So if we continue this pattern, when we get to negative 1, we're going to take this result and add 3, which gives us a positive 3. If we go on to the next one, negative 2 times negative 3, we'll take this result, the 3, and add 3 and get 6. And it continues. Negative 3 times negative 3 is a positive 9, because we're adding 3. And negative 4 times a negative 3 is a positive 12, because we're adding 3. We can also, again, look at the repeated addition. However, we're going to make a minor modification to that. So recall from before, 4 times 3 is 4 added to itself 3 times. If we do 4 times negative 3, instead of adding to itself, we're going to be subtracting 4 repeatedly. So it'd be subtract 4, subtract 4, subtract 4. If you subtracted 4 3 times, you'd be subtracting 12, or a negative 12. 3 times negative 3 would be subtracting 3 times and give us negative 9. 2 times negative 3, subtracting 2 3 times, and so on. Notice here I do not write a negative 0. 0 does not have a sign. It is neither positive or negative. However, now when we get into the negatives, we're going to be subtracting a negative 1 3 times. But when you subtract a negative, remember that what you're really doing is adding a positive. So that's how we wind up with a positive 3. And again, if we're subtracting negative 2 3 times, we're actually adding that positive 2 3 times. And the pattern continues. So, another example. Multiplying the integers negative 10 times negative 6. Since they are both negative, the result will be positive. 10 times 6 is 60. Since they're both negative, it's a positive 60. Multiplying the integers, what to do when you have more than one. If you have parentheses, you do what's in the parentheses first. So 4 times negative 5 is negative 20, and then you just multiply negative 3 times negative 20, and you will get a positive 60. Here we have negative 2 times negative 2 times negative 2 with no parentheses. If you have no parentheses, multiply the first pair together first. Negative 2 times negative 2 is a positive 4, times a negative 2 is a negative 8. Now we will look at some properties of multiplication. The multiplication property of 0. Multiplying anything by 0 gives you 0. So it doesn't matter what you're multiplying by. If you multiply by 0, you get a 0. This becomes very important. When we get into algebra, you will see certain rules, and they will have a caveat that it can't be 0. And that's because anytime you multiply by 0, it turns the number into 0, and that can undo a lot of your work. So be careful with zeros. The next is the multiplication property of 1. Multiplying a number by 1 does not change it. So 6 times 1 is still 6, negative 12 times 1 is still negative 12, and 1 times 5,876 is still 5,876. This becomes very important when we get to fractions. We are going to use the fact that multiplying by 1 does not change anything to make our numbers look different without actually changing their value. So this will be very important when we get into fractions. This will also be very important when we get into algebra as well. Another property of multiplication is the commutative property. Changing the order when you're multiplying doesn't matter. So 2 times 5 is the same as 5 times 2. They're both 10. And negative 4 times 6 is the same as 6 times negative 4. They're both negative 24. When we are dealing with just numbers, this property seems very silly, but when we get into algebra, this property will be very important. Now we will look at an example illustrating the commutative property. So negative 7 times negative 4. No matter which order you put them in, they both come out to be a positive 28. And lastly, the associative property of multiplication. This says that changing the grouping of factors does not change the product. So it does not matter which two you multiply together first. I should note that this is only true when it's all multiplication, or as we saw earlier, when it's all addition. When you mix multiplication and addition, or multiplication and division, then this does not apply. This only works because it's all multiplication. Here's an example. We have 5 times 10 times 2. One option is to start with the 10 times 2. Another option is to start with the 5 times 10. If we look on the left side, if we start with the 10 times 2, we get 20, and then 5 times 20 is 100. On the right side, if we start with 5 times 10, we get 50, and 50 times 2 is 100. Notice that both products are 100. It does not matter which one you start with. And lastly, this is not necessarily a property of multiplication, but instead a property of multiplication over addition. It is called the distributive property. When you have a multiplication outside of parentheses and an addition inside, you can distribute that multiplication. So this means 3 times. You can take that 3 times and distribute it. So 3 times 6 and 3 times 2. This is very important in algebra, and a lot of students make silly mistakes with the distributive property. So now let's look a little closer at it. We can distribute that negative 2 to both values. So you have negative 2 times the negative 5 and the negative 2 times the 1. Let's simplify both sides to show that they are equal. On the left, we start with the parentheses. Negative 5 plus 1 is negative 4. Now we carry down the negative 2 and do negative 2 times negative 4 is positive 8. On the right, even though we have multiplication and addition, order of operations says we need to do those multiplications first. So negative 2 times negative 5 is 10, and negative 2 times 1 is negative 2, and then we do the addition and get 8. We will talk more about order of operations very soon. Again, both results are 8. Lastly, we'll estimate answers to application problems involving multiplication. Last year, Netflix had to replace 392 defective DVDs at a cost of $19 each. Estimate the amount of money Netflix lost on the DVDs. We're going to estimate using front-end rounding. So 392 rounds to 400, and negative 19, it's a negative because they had to spend $19, so they lost $19, rounds to negative 20. Then we would multiply 400 times negative 20 is negative 8,000. So notice the 4 times the negative 2 is the negative 8, and then we have those 3 zeros. Multiplying with zeros is actually pretty easy, which is why front-end rounding makes rounding with multiplication pretty easy. Again, I should note this is the estimated answer. If we want to find the exact answer, oops, that's a typo, that should be exact. The exact answer is 392 times negative 19. This winds up being negative 7,448. That would be the exact answer. So, what are your next steps? Complete the worksheet for section 1.6, WS6. Check the key for worksheet 6 in D2L. Complete the online homework for section 1.6, which is OH6 through My Math Lab. After that, if you would like to, you can start on section 1.7, but that is not due until next week.